So welcome to my talk, which is about pathways, not pitfalls, building platforms with developers in mind. But before we jump into that, I actually want to talk about what platforms actually are. Because the term platform is quite overloaded, so today we are going to focus on so-called developer or productivity platforms. And those platforms have one main goal. It is to reduce the cognitive load of developers, and by that, to allow them to focus on innovation. And how is this done? Basically, in a very, very small nutshell, you're pulling all the repetitive tasks around building, testing, deploying, and observing an application into one central hub, into one central platform, and then the developer can consume those building blocks, those tasks, in a self-service manner from the platform. So basically, what we want to do is we want to create a self-service heaven for a developer. Or in the definition of the Vortrag blog, who have put it much nicer than me. Sorry for that. Yes, now it is working. Platforms are a means of centralizing expertise whilst decentralizing innovation to the user or customer. This means we are centralizing the expertise about building, deploying, observing, and so on applications into our platform, but we are decentralizing innovation to the developers and still allow them to work in their own way. And today we are going to take a look at those platforms, how they can build, at least in a very overview, and how users can actually interact with such developer platforms. But before we do that, who am I to talk about this? My name is Katharina, or actually Kati. According to my job title, I'm a software engineer at Dynatrace, but actually I have fully merged now into the fascinating world of DevOps, cloud native, platform engineering, and I have to say I really, really enjoy what I'm doing here. But that's already enough about me. Let's go back to platforms. When we're building platforms, we are offering self-service capabilities for developers. So what's the catch about this? Platform engineers are very often people with operations and DevOps background. But suddenly, we are offering some interface to the developers that they can consume capabilities of the platform. So suddenly, we as platform engineers with operations background need to have UI UX skills as well, because in the end, every platform is offering a user interface somehow. This can, for example, be a command line interface. It can be an HTTP API. It could be a Git repository if you're doing GitOps. It can be a developer portal like Backstage, Port, or Cortex, for example, or maybe a combination of those, or anything else you come up with what makes sense in your organization. So we as platform engineers now have to build nice user interfaces. And yes, a command line interface is a user interface too. Because by doing that, we decide over the success of our platform. Because in my opinion, getting the user interface right is very important for platform adoption. Because if you get it right, more and more developers will come and will like to use your platform, and your platform will be successful. But if you get it wrong, you might end up like these people on Reddit who have spent months building their platform. Developers hate it, and they don't know why. But that's it about platform engineering. You cannot just sit in your room for months and build what you think is useful. You really have to talk with developers. You have to talk to your users, get their requirements in, and then build something they actually want to use. So how can you do that? How can you build a successful platform? Well, the first thing I have to tell you is the thing that we all hate to hear. It depends. You really need to find your very own needs, because every platform is different. And if it wouldn't need to be different, I don't think that so many companies would be building platforms right now. But when building a developer platform, it needs to respect the domain it is being built in. So it needs to respect the use cases of your company, and also, your needs, your requirements, your stakeholders. Really find what that is. And then, once you have that information, get focused and define a mission. So really think about which problem do you want to solve, how do you want to solve that problem, and also which problems do you don't want to solve with your platform, or which problems do you not want to solve now. And when thinking about this mission, it is very important to focus on the problems you want to solve and not the tools you want to use in the beginning. Because I had many discussions with people about platforms, and I noticed after like 2 or 3 minutes, it often gets into the tools very quickly, because we all like using them. But actually, we should take a step back and think about what we want to do first, and then think about how we want to do it. Next thing, design for a good user experience. With that, I'm not talking about creating pretty UIs. I mean, I think they are important, and I really like using pretty UIs. But here, I'm talking about user experience. When a user does something on your platform, for example, if the user wants to deploy an application to the platform, they shouldn't have to read like pages and pages of manuals to do that. Actually, we should create a design that guides them in the direction of deploying that workload, and the manual should be just an addition to that. Yeah, the next point that is important to me is starting small. We as platform engineers are in the lucky position that developers have built products for years or even decades now. So why not copy a bit from them, and why not learn from them? So we can go ahead and take a look at Agile, for example. It is working very, very well in app and product development, and there's the concept of the MVP, of the minimum viable product. And what you do there is you start really small, you ship it to the customer, you get feedback, you iterate from there, you improve again, and so on. And the same concept exists for platform engineering. In this case, it's the thinnest viable platform. So basically, you start with a very small platform. It could be just a wiki page with like descriptions on how to use a cloud provider. Then you get people to use that, you get feedback, improve it again, iterate. And you will get much, much more feedback, like the people on Reddit we took a look at earlier, to actually find out what people really need. And the last thing, make your platform observable. By making your platform observable, you will be much, much faster with troubleshooting. And let's face it, platforms are complex things, so probably you are going to run into errors sooner or later. So by making them observable, you will be much faster with like realizing that there is an error, probably also realizing before a user tells you, then finding the root cause and fixing the problem. And at the same time, with observability, you can check how many people are using your platform, and also how many people are returning, which features are used more, which features are used less, and where do people maybe leave the platform, so where do you need to improve again. Okay, so there are 5 points now: finding your needs, having a clear mission, designing for a good user experience, starting small, and making your platform observable. And all of them sum up to treating your developer platform as a product. Because in the end, that's what it is. You don't have any external customers. Your customers are your developers, but still you should make sure to treat them as they would be external customers. Because in the end, they decide over the success of your platform, either by using it or not using it. And the nice thing about that is you can talk to them. You can schedule coffee calls. I know it's a hard thing to do, but it's really easy to approach something, have a coffee with them, ask them for their needs, and it will make your platform so much better. If you're interested in that, I've also done a longer talk that basically contains this introduction in, I think, half an hour or 40 minutes. So here's a QR code. I will also upload the slides later on, but yeah. And that's it about platforms now. Now let's talk about abstraction. So we need our users to interact with our platform in some form, because they are doing things in a self-service manner. So we need to provide a user interface. And to provide this user interface, we can use abstraction. Because I want you to imagine you're going to a restaurant and you're ordering a burger there. But instead of getting a burger when the waiter comes back, you actually get some bread, some lettuce, meat, cheese, and tomatoes. And maybe a small stovetop and a pan to prepare everything yourself. Well, not the best experience, right? You could have probably made a better burger at home because there you have better equipment. So now I want you to imagine going to another restaurant. And this time you go there, you order a burger, and what you get is a burger. Much, much nicer, isn't it? And it's actually the same about platforms. A platform is not just the things it is made of. It's not just the ingredients of a meal. It is really about how well those ingredients, how well those components are connected to a whole, and how well they are coming together. Or, as Gregor Hopper has put it in his book, however, the value of the platform doesn't just derive from its scope, so the elements it contains, but also from how these pieces come together to form a meaningful whole. And to me, this meaningful whole is the most important thing about platforms. In my opinion, it's much, much better to have less features, but to have them connected well, than to just have a huge set of ingredients that you're throwing at the user and they don't know what to do with it. So how can you do that? How can you connect certain ingredients, certain components to one whole thing? This is where the power of abstraction comes in. And abstraction can actually be done with many tools, but we at Dynatrace are using Crossplane and Backstage heavily for that. As said, there are lots of alternatives. Also, there are way more alternatives than listed here, but you could achieve similar results with Kubevela and the Open Application Model. You could use Helm, which I don't like that much personally, but you can do it. And for Backstage, which is a developer portal, you can also use Port or Cortex, which are not open source, but they look very promising. But today, we are going to focus on Crossplane and Backstage. They're both open source, and they're both very widely used, but still the concepts apply to many other tools as well. Let's start with Crossplane. The first thing that Crossplane is known for by many people is infrastructure as code. And that's, in my opinion, the first superpower of Crossplane. So basically, it is a Kubernetes operator. You just install it to your cluster, and then you can create custom resources that are actually provided by different providers. So there's one for Google Cloud, there's one for Azure, there's one for AWS, but also for less obvious things like, for example, for GitHub to create repositories, or for many, many more things. And even if you want to manage on-prem infrastructure with Crossplane, you can do that by adding your own provider and then interacting with the API. And then those providers will interact with their target systems, which would be Google, Azure, and so on. Okay, how does that look like for creating a database with Crossplane and GCP? The first thing we need to do is we need to create a database instance. Here you can see that it's of API version sql.gcp.upbound.io because it is provided by the GCP provider that has been created by Upbound. And the thing we are creating is a database instance. And the name of this instance is CNCF sample instance. I'm sorry, I was not the most creative person during creating these talks, but you can imagine a very nice and hopefully funny name here. And then we need to configure our provider, or actually we need to configure the resource our provider needs to create. In this case, we're using a Postgre database. We don't want deletion protection. We can configure how the database is replicated, which disk size is had, which instance size it is using, how backups are done, how networking is done, and many, many more things that didn't fit on this slide. And once we have the database instance, we can create a database from that. This one is much simpler. We have the same API version again because it's provided by the same provider. We have kind database this time, so this is different from the database instance. We have a name, which is the CNCF sample database. And in the spec, we simply link to the instance that we have just created. And once we go ahead and do kubectl apply those two files to our Kubernetes cluster, Crossplane will notice, hey, those are my custom resources. So I'm going to go ahead, I will take care of them, and I will actually deploy them to Google Cloud, where you will get a CNCF sample instance, which we have created on the left, and a CNCF sample database, which we have created here. The Postgre database is just there by default. That's why you don't see it anywhere here. The thing about this is to create this database, you can do it via Crossplane, completely as code, but still you need to have a lot of GCP knowledge. You need to configure this networking, the backups, the replicas, the instance types, and so on. And at the same time, you need a bit of Kubernetes knowledge to at least know how to kubectl apply or which repository to push this to. So we can make this simpler. Let's say a user wants to create an application with a database. We already have a database instance and a database. But for an application to connect to it, we need a Kubernetes deployment. We need a service. We probably need an ingress and some DNS configuration so that the web app is also reachable somewhere. Quite a lot to understand, right? Especially if your main focus is software development, then you have to know the GCP internals, you have to know the Kubernetes internals, you need to know how those components connect with each other, and probably you're going to have some problems and you also need to learn how to fix them. So we as platform engineers can do much better than this. What we can do is we can combine all of that into one single type that is called application. And this is the second and maybe even more important superpower of Crossplane in my opinion. It's called composition, and by that you can compose a set of resources into one very simple resource. So for the end user, it would look like that. You would just have one very small YAML. The API version is something custom to us. It's demo.cloudnativelinz.github.io because I defined this. Then we have kind application. It's named My Fancy App. We provide a domain for which it should be reachable on the internet. And we say, hey, please give me a database and I need that much disk space. And by applying that, the developer doesn't need to know about how a service is working, how an ingress is working, how to configure networking on GCP, because it simply doesn't matter for developers, in most cases at least. So we can make developers' lives much easier by creating meaningful abstractions. And coming back to the burger example, the left side would be the ingredients, and this is now the burger we get in the restaurant. Okay, so how can abstraction be done in Backstage? Before I start with that, a little disclaimer. It's very arguable if you want to call this abstraction or not, but it helps us to simplify the user interface, so that's why I have added it here. Basically, Backstage is a developer portal that aims to be the user interface of your platform. So Backstage has a service catalog where all components that are deployed to your platform are registered. It has support for documentation, so you can view and search documentation directly in Backstage. It is highly extensible, has tons of plugins, and it has one more great thing, which is the scaffolder. In the scaffolder, you have templates. You can select those templates and then create instances from them. So in this case, we have an application template again. We can choose this one and enter some inputs that, again, the platform engineer or the one creating the template defines. In this case, it's pretty much the same as before. So we want to have a database again. The name is My Fancy App again. The disk size is 20 gig. We are defining an owner because this can be added directly to the service catalog of Backstage again. So ownership information is nice to have. I felt like adding an alerting Slack channel, so I also added this one. And we provide the repo that everything is going to be templated to. And once the user then clicks on create, Backstage will execute a predefined set of steps. In this case, generating all the files. So generating the files for database instance, for database, for deployment service, ingress, and DNS configuration. And will then also generate an empty doc template for us so that getting started writing docs is much, much easier. Once this is generated, it will publish it to GitHub. And after, in total, I think 5 seconds, it is done, registers it to the catalog so that we immediately see the component in Backstage and we are good to go. The nice thing about this is with those templates, we have a searchable UI where you can register all your templates and they're easy to discover for the user. The not so nice thing about this is if the user wants to change something later on, they still have to deal with the complexity of GCP, Kubernetes, and so on, because they still have all the ingredients listed instead of the fully fledged burger. So what I really like using is Crossplane and Backstage together. So use Backstage for the templating, for the discoverability, for the UI, to give the user the chance to input things. But then, instead of templating the deployment, service, and so on, you name it, to the repository, deploy the Crossplane application, so the composition we previously created. Because like that, you have a very nice UI for creating, but also updating is very easy for the user because it's easier to understand. Okay, enough about tools. Let's get back on how to do abstraction. Because unfortunately, making things simpler isn't always simple. When I first heard about cross-plane Backstage, I was like, hey, let's go ahead, let's abstract all the things. But I actually soon noticed that I did too much. So I want to share 5 points with you that I think are very important when doing abstraction. And the first one is, again, very similar to platform engineering, really focus on your user. I cannot say this enough. Talk to your developers, find out their needs, and build for their problems and for their use cases, because then people are going to like using your platform and your abstraction. The next thing is, abstractions need to respect the domain they're built in. It is the same for platform. It should also respect the language of the domain. So just like in domain-driven design, the same language should be used across all components. And this shouldn't actually stop at the platform. But the platform is part of the domain, and the name actually also evolves from the domain. I know this is very hard to do, and as one of our favorite organizers told me on Friday, naming is always hard in IT. But still, I think we can try our best to create good names and actually build our abstractions outside in and not focus on the components they exist of, but the use cases in our domain they are solving. Next thing is provide opinions, not restrictions. Basically, when creating abstractions like the one I showed you with crossplane, you have two main choices. The first one is you can simply leave out values completely. Like I did it before, you just can set, if you want a database, you can set the disk size and the domain name, but everything else is not configurable. And this can lead to a lot of problems, because basically this abstraction was serving one use case very, very well, but it was just one very thin path. And developers, especially if they lived like the DevOps culture, they are used to doing their deployments on their own, and they're used to deploying things in their own way. So we must not only supply like one path that everybody, so like on this one path the experience will be good, but only a little bit to the left and a little bit to the right, it will drop down to 0 because they need to work against the platform then. So instead of that, we can provide opinions. So we can set defaults and we can still make the interface as small as before. But if somebody wants to configure more, they have the possibility to do so. So basically, the experience on our path is still the best, but a little bit to the left and a little bit to the right, it is still good. And the nice thing about opinions, we can have multiple ones of them. Who limits us to one opinion? So we can provide this path, but at the same time, for the other team that has another use case, we can provide this path. And that's a very nice thing about opinions. Be transparent. If you restrict something because of a certain decision, document it and communicate it to developers. Especially for me, and I think for many others as well, it is much, much easier to accept something if you understand why it is like that. Also, if you create an abstraction like application, give developers the chance to understand what is going on underneath. I know I told you that developers shouldn't have to care about this, but if they want to, they should be able to do so. Because we don't want to restrict them, but we really want to guide them and to make their lives easier. And last but not least, show the right information at the right time. This might sound easy, but it's actually a super hard thing to do. Because let's think about it. At creation time, you're probably only interested in parameters you're providing. But then your application is maybe running, you're now interested in performance issues, how you can improve there, so you want to show that information. If a problem is happening with the deployment, you want to show what is going on. So let's say I'm deploying my application with the database again, and something on GCP is failing. The worst I could do as a platform engineer is to not propagate this error to the user, because then simply the database is not there and nobody will have an idea what is going on. You could propagate the error simply through, then it's a bit better. But still the abstraction is leaking the underlying infrastructure of GCP. It is still better because the developer can read the documentation, can reach out to the platform team, and they can fix the problem together. But maybe, and this is now the hardest thing, and I also don't know how to do that, but maybe you can also prevent that leak and show a very good error message, because you know, hey, this might happen. So you maybe also prepare for that error and immediately tell the user, hey, this has happened, do that, or maybe this value is misconfigured, you change it to that, for example. But in the end, most abstractions will leak at some time. So be prepared for that. Okay, so focusing on the user, understanding the domain, providing opinions, being transparent, and showing the right information. I think if I would have known that when I started with abstractions, I wouldn't have gone ahead and tried to restrict everybody, because I thought I have a background as a mobile engineer, and at that time I was not interested in CI/CD or cloud native at all. I basically wanted to write my code. I wanted to write it as good as possible, but everything after my pull request didn't bother me, because I don't know why, but it was like that. And actually, I had this in the back of my mind when starting with abstraction. And so what I did was that I was trying to apply my mental model to all the developers in our company. And that's simply not the way it works. We are all different. We have different imagination of how something should be working. We have different workflows, and we also have different ideas about this. And I really believe that we as platform engineers should respect that and keep it up to the developers how they want to use the platform. So, how do you now do abstraction? Well, the long story short of my talk, unfortunately, is again, it depends. You really need to find out about your users. Sorry for emphasizing this again, but talk to your users. Really start small with the thinnest viable product and then improve from there. And then I think this is the best approach to platform engineering and abstraction, because then if you do something wrong, you will notice early and you can change the direction you are going to. Okay, so we have covered quite a lot today. We have started with what platform engineering is. We've journeyed over the thinnest viable product. Then we went to abstraction and why it is so important, and when abstraction also becomes too much, and when you do no good with it anymore. And all those things we've talked about are basically from those resources. The biggest block is probably Platform Strategy from Gregor Hope. I can really recommend this book if this talk was interesting for you. It's also surprisingly fun to read for a tech book, so I think I never enjoyed reading a tech book that much. I have to admit I haven't fully finished it yet. I'm at 3/4 or something like that, but Team Topologies is also a great book. For example, the thinnest viable platform was mentioned there. I've read it years back, domain-driven design, especially for ubiquitous language and for understanding the domain. This is a great resource. I always get great inputs and information from the DevOps Toolkit from Viktor Farcic on YouTube or the Vortrag blog and podcasts. And the most important thing, a lot of interesting conversations with people like you. So keep it up, let's grab a drink afterwards. And if you have any questions, feel free to ask. Thank you.
Backstage a lot, and I tried to look into it at some point, and it looks very nice, it looks very promising. My biggest issue with it so far was it looks quite expensive to maintain, so I would be particularly interested in how you guys are doing that.
Actually, it needs quite a lot of people to maintain it, yes. So we are a team of 7 people, I think. And half of our focus is on Backstage, on building features, on testing plugins, on integrating them. So it actually needs quite a lot of focus, especially if you want to customize it to your company, which you should do in my opinion, because...
Are you dealing with updates? Because if you're customizing from basically, or starting a fork from Backstage, which seems to be the way to go, if I understand it correctly, at least if you're not building plugins.
Basically, you're not really forking it, but you're using a lot of node dependencies, including Backstage, which is the framework you're building in, and you always update the version of those dependencies. We're doing that, we're updating that with Renovate most of the time, and if we're having any problems, there are nice CLI commands from Backstage themselves, and you can use them, and it works quite well to keep it updated. I think you were first.
Do you know how many of your users, developers, have an idea of everything that is behind the abstraction?
Unfortunately not. Unfortunately, we are also not that far yet with abstraction, so I took a lot of information that is in here from the books. We're also not that far as we should be with observability yet. So we are still in the process of finding that out. So maybe in the next few meetups I can tell you a better answer, but for now, I'm sorry.
So you mentioned these cross-plane applications. Can I think of those like kind of a Terraform module?
Yes.
Seems like it.
It's pretty much the same. So you're composing a set of resources into like one smaller thing. And the only thing that pops out is like not the Terraform thing, but a Kubernetes YAML or a custom resource definition that you can then apply. But it's pretty much the same concept.
And one more question. I saw your talk like a few months back at Dynatrace. There you also held a talk about crossplane.
Mm-hmm.
So back then it was still like kind of beta. So do you see any improvements on that?
A lot actually. Yeah. So especially now 1.15 was released like I think 1, 2, 3 weeks back, something like that. And with 1.14, which was before that, they had a lot of improvements. And you really feel that it's getting more stable and more mature now. So I really enjoy using it. Of course, there's still some few problems we are fighting with not each day, but from time to time. But it improved a lot since last year.
Are you using it for production deployments?
Are we using it already? No. Not yet, but we're getting there, I think.
Getting close. Okay.
Yeah.
Nice. Thanks.
You talked about this opinions and to open them to the users. I'm interested in can you measure it somehow? Which opinions, which paths are taken and which are not? Because in my experience as a product manager in my past years, it was always hard to measure the usage of a product. Besides of talking to the people, which is good, perfect. But how can you measure which features are used and which are not?
We haven't done it yet, so those are just rough ideas I had while you were talking. But for example, if you're using Backstage to initialize things, you could track how many people are using a template and also how many people are getting finished through actually like creating the stuff you need. Or with Crossplane, you could maybe also check like how many types or how many times each composition is deployed. That would come to my mind right now. But I guess we also still have to gain some experience on that.
I would assume an application CRD like you added in your example is something that everybody wants to build, abstracting away the complexity of database and everything. Is Upbound or anybody else in the community defining some higher level abstractions of a set of apps already, or does everybody need to define their own apps?
There are actually some examples, especially from Upbound and from the DevOps Toolkit YouTube channel. For example, for EKS cluster, where they have lots of reference architectures that look the same for many companies, and you can get inspiration from them or even use them. But in my opinion, for applications or for microservices, it's a bit harder. There are, of course, also applications out there. But again, with like really building them for the domain they are used in, I think you need to have your custom applications, but especially for smaller things. Like an EKS cluster is pretty hard to create. It is also possible, we have done that in the team, but there are so many things you need to consider. But for like a smaller application with like a database with maybe observability and so on, it's much, much easier to write these compositions, and they also have very good documentation on that.
You said that you are not far yet on the monitoring. Does either Crossplane or Backstage have any integrations with OpenTelemetry or any observability tool at the moment?
Crossplane is relying on Prometheus metrics a lot. And I know that there are some open GitHub issues where they are discussing migrating to OpenTelemetry. But there's, I think, no work, it's just discussion yet, but it seems like they're very, very in favor of doing that. So what Crossplane does at the moment is like Crossplane itself, and most of the providers, at least the ones created by Upbound, do expose Prometheus metrics that you can then scrape and get some useful information out of that. For Backstage, they are also offering some metrics, but to be honest, I don't remember which kind it was. I'm sorry about that. But for that, we use like the standard Kubernetes monitoring a lot to get like events, errors, HTTP requests that maybe fail, CPU, memory, and that stuff. And that works pretty good for us.
Awesome. Thank you. Cool. Yeah. So.
Cool. Thank you.